Greetings, everybody. Today we are going to spend time talking about section 2.2 and 2.3 in your textbook. So let's just go ahead and get this started. We're going to start off with physical properties. A physical property is anything that you can measure or observe without changing its chemical properties or chemical nature. That's what I mean by that. You're not doing anything to it. You're just looking at what it is. So two types, extensive and intensive. Extensive depends on how much matter is present. So volume, mass, length. Do I have 5 milliliters? Do I have 50 centimeters? Okay, things like that. Intensive does not depend on how much matter is present. Melting point, boiling point, color, density. Water boils at 100 degrees C, whether you have 5 milliliters or 500 milliliters. It's always going to boil at 100 degrees C. It doesn't matter how much there is. Example of a physical property is density. I'm not changing anything about density. So density is a measurement of how much matter is contained in a certain volume. It is calculated by dividing the mass by the volume. And then here is the lovely density formula, which is mass divided by volume. And with the help of doing a little bit of algebra, we can solve for other parts of the density equation. So we have density formula solving for density, but I can also solve for mass and for volume just by rearranging the variables. So those are the other formulas that we can use. Units are usually grams per milliliter or grams per centimeter cubed. Point of note, water's density is always 1.00 grams per milliliter. If something floats, density is less than 1. And if something sinks, the density is greater than 1. So just by taking something in water, you can get an idea of their density just by seeing if it sinks or if it floats. So let's do a little math problem here, okay? Determine the density of a 343 gram object that occupies 1033 centimeter cubed of space. So density formula is mass divided by volume. So I'm going to take 343 grams. Notice I'm putting my unit in my work here, divided by my volume, 1,333 centimeters cubed. And I go to my calculator, which I have off to the side here, 343 divided by 1033. And I'm going to take 3 decimal points. We're going to get 0.332. And my unit is grams per centimeter cubed. And this would float because it is less than 1. So there is an example there for you, okay? Next one, how much does a piece of aluminum weigh if it has a density of 2.702 grams per centimeter cubed and occupies 9.18 centimeter cubed of space? So this question here is asking for how much it weighs. So we're going to look at mass. So I'm going to go back up to my formulas here, and it's looking for mass. So this is the formula that I am going to use. So I'm going to take density times volume. So I'm going to write this here. Mass is density times volume, okay? So my density is 2.702 grams per centimeter cubed, and my volume is 9.18 centimeters cubed. Go to my trusty calculator here, 2.702 times 9.18 equals 24.8, and my unit is mass, which is grams, and there you have it, 24.8 grams. Okay. So that's density. Those are some density problems for you. Then you'll have the opportunity to do some practice on that coming up. Okay, so let's move on here. Physical change. A physical change is change that affects physical properties, mostly notable going from a solid to a liquid. A phase change is a physical change. Chemical property is a property that can be observed with how they interact with one another. So when you put it next to something, what happens with it? Okay. Chemical properties are characterized by how they react with one another. So that's that interaction piece. When you put them next to each other, how do they react or how do they interact with one another? Okay. Example, helium is very unreactive. That's why we put it in our balloons, because it does not react with anything around us. So it's very good for balloons. Sodium, on the other hand, just pure sodium, is very, very reactive with water. It is so reactive, actually, that it will react with the water vapor that is in the air, that it has to be stored under mineral oil so that it does not react with the water vapor that is in the air, because it is so violent with water. Reactivity is a term that will be popping up every once in a while. It is the capacity of a substance to combine with another. Again, how does it react with one another? Flammability, the ability to burn, flammable, flame, burn, all those terms kind of come together. All right, a chemical change is a change that produces one or more new substance. That's the new term, or that's the key part of that definition. Okay. During a chemical change, there's a change in the way that the atoms are bonded together. What happens in a chemical change? The their bonds are broken, and they simply rearrange and then rebond back together in a different way. That's what's happening during a chemical change. You take the bonds, you break them up, you let the atoms change and circle around and interact with one another, and then they rebond in a brand new way. A chemical bond is the force of attraction between two atoms that are held together. A chemical change means the same thing as a chemical reaction. And I use those terms interchangeably. I don't tend to stick with one or the other. I use them interchangeably. Chemical reaction, that RXN, that's just the abbreviation for reaction. Chemists get a little sloppy with writing reaction, because reaction is kind of a long term. So we like to make it a little faster. And so we shorthanded it to RXN. So a chemical reaction is what the new materials are formed by the change in the way the atoms are bonded together. Determining a chemical or physical change. After a physical change, the molecules are the same ones that you started with, okay? In a phase change, okay? And you can't read that. My handwriting is too sloppy. In a physical change or a phase change, water in the solid phase is H2O. Water in the liquid phase is H2O. Water in the gas phase is H2O. The chemical formula of H2O has not changed going from the different phases. That is a physical change. The molecules have not changed. They are the same as what you started with, okay? Whereas in a chemical change, the original ones have been destroyed and you get new ones in their place, okay? One thing that I like to do is that I like to give you a little drawing here, okay? This is a physical change, okay? This is a physical change. I went through a phase change. I went from a solid to a gas, okay? But on the other hand, a chemical change looks something like this, where you have one atom that's colored in, one atom that's open, and it goes to now you have two atoms that are colored and two atoms that are uncolored, okay? We went from one colored, one uncolored bonded together, and now we have two uncoloreds together and two coloreds together. This is a chemical change. Just another way of visually writing and drawing a picture of what's going on, okay? Now, there are ways of figuring out whether or not a chemical change has taken place, and that is what these 5 are. And don't ask me why they all are not labeled number 1. They should be labeled 1 through 5. But here's what you've got, okay? You've got the evolution of a gas. So a gas is giving off, okay? The second one is the formation of a precipitate. A precipitate is a solid being formed. The evolution or absorption of heat. So this is a temperature change. It gets hot or it gets cold. That's what temperature is. It's an absorption or evolution or release of heat. That's what I mean by evolution. It's a release. So maybe we should write that down here so that we're all on the same page. Evolution is the release of heat or release of a gas, as it is for number 1, the evolution, okay? The fourth one, emission of light. Again, that's light being given off. And then the fifth one is a color change that has occurred in the system. So those are the 5 things that you can look for. If you see any one of those 5, you know that a color change or a chemical change has occurred. And that takes us to the end of the notes. So there you go. The next thing that you will need to do is take the quiz that goes along with these notes for 2.2 and 2.3. And again, if you have any questions on anything, please do not hesitate to come and ask, especially with the density and the calculations. And then you're going to do some practice with identifying physical and chemical changes, as well as physical and chemical properties. And then you'll be doing some density work as well. So good luck. Let me know if you have any questions. And that is it for right now.